Lesson 8.7, Sample Space. The essential question, how can you describe the possible outcomes of an event? Explore Activity 1, Finding the likelihood of an event. Each time you roll a number cube, a number from 1 to 6 lands face up. Work with a partner to decide how many of the 6 possible results of rolling a number cube match the described event. Then order the events from least likely, which will be 1, to most likely, which will be 5, by writing a number in the box to the right. So you're not going to do this with a partner. You're going to do this with this video. What I want you to do is look at all of the possible outcomes here, where they have rolling a number less than 6, rolling an 8, rolling a 5, rolling a number less than 5, and rolling an odd number. And if we think of a number cube, we're either going to land on a 1, a 2, 3, 4, 5, or 6. So to roll a number less than 7, well, all of the numbers are less than 7. So that will happen 6 out of 6 times, which is the same as 1. So that means that is certainly going to happen every single time. Then if we look at the next one, rolling an 8, there is not an 8 on a number cube, so the probability would be 0 out of 6, which is 0. So that event is impossible. Then we have rolling a 5. So there's 1 5 out of 6. So that will happen 1 out of every 6 times you roll a die. So that's very unlikely. Then the next one is rolling a number less than 5. So we can see here we have 4, 3, 2, and 1. So that would be 4 out of 6 outcomes, or 2 out of 3. So that is a pretty likely event. That means for every 3 times you roll the dice, you would expect twice for you to get a number less than 5. And then rolling an odd number. So 1 is an odd number, 3 is an odd number, and so is 5. So that's 3 out of the 6, or 1/2. So that means it's as likely as not. So now what we're going to do is, it says order the events from least likely, which is 1, to most likely, which is 5. So if we look here, 0 is the least likely to happen. It's impossible. And 1 is always going to happen. It's certain. So those are going to get the 1 and the 5 there. And then the lower probability here is 1 out of 6. So that would be 2. And then 3 would be as likely as not for rolling the odd number. And then 4, 2 out of 3 is very likely. The reflect question asks, are any of these events impossible? And if we look here, rolling an 8 was an impossible event because it happened 0 of the 6 possible times. So we would write yes, rolling an 8. Describing probability of events. An experiment is an activity involving chance in which results are observed. Each observation of an experiment is a trial, and each result is an outcome. A set of 1 or more outcomes is an event. The probability of an event, written as P in parentheses event, measures the likelihood that the event will occur. Probability is a measure between 0 and 1 and can be written as a fraction, a decimal, or a percent. If the event is not likely to occur, the probability of the event is close to 0. If an event is likely to occur, the event's probability is closer to 1. A sample space is the set of all possible outcomes for an experiment. A sample space can be small, such as 2 outcomes when a coin is flipped, or a sample space can be large, such as possible automobile license plate numbers. Identifying the sample space can help you create the probability of an event. So this should be a refresher, but the probability of an event is the number of outcomes in the event over the number of outcomes in the sample space. Example 1. What is the probability of rolling an even number on a standard number cube? So step 1 is find the sample space for a standard number cube, and they list them right here, showing that there are 6 possible outcomes. Step 2, find the number of ways to roll an even number. So we can see you can get a 2, a 4, or a 6, so there are 3 different ways that event can occur. Step 3, find the probability of rolling an even number. So we would write this as the probability of an even number is equal to 3, which is how many times you can get an even, over 6, which is the total number of outcomes. And then 3 over 6 can be simplified to 1/2. So the probability of rolling an even number is 1 out of 2. Explore activity 2, using a table to list a sample space. Roberta and Will are playing a game where each player rolls 2 number cubes and adds the result. So we already did this. You can see that they have a red cube, and on the red cube you can get a 1, a 2, a 3, a 4, a 5, or a 6. And then they have a yellow cube, which again you can get a 1, a 2, a 3, a 4, a 5, or a 6. See if you can remember how to fill in this table. Here's the table filled in so you can check. So remember, everything in this section right here are the total outcomes, and there were 36 possible outcomes that could happen. So now we're going to use the table to answer the following questions. The first one is, what outcomes can be rolled the greatest number of ways? What is that number? So if we study the table here, we can see going in the diagonal that you can get a 7, 1, 2, 3, 4, 5, 6 times. And all of the other numbers are going to be less than that 6 times. So we would say 7, and then you can get that 6 out of the 36 total times, which is 1 out of 6. The next one says, what outcome can be rolled the least number of ways? What is that number? And so if I look here again, 2 and 12 can both only be rolled 1 time. So we could write 2 and 12, and those both occur only 1 out of 36 times. For D, it says how many possible outcomes are there? And so if we add up all of the numbers here, there are 36 possible outcomes. E, if Will rolls a total of 6, how many outcomes in the sample space can Roberta roll that will be higher? So we want to count everything that is greater than 6, so that would be on this little section of the chart. So 1, 2, 3, 4, 5, 6 for 7s. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we would say 21. F, if Will rolls a total of 6, what is the probability that Roberta rolls a higher total? Express your answer as a simplified fraction and as a decimal, round to the nearest thousandth. So in order to figure that out, we have to take 21, which is how many numbers are greater than 6, out of the total numbers, which is 36. We could divide both these by 3 to get it simplified. So 21 divided by 3 is 7, and 36 divided by 3 is 12. To turn that into a decimal, I'm going to divide 7 divided by 12, and that gets me 0.58 and then 3 repeating. So if I round that, it would be 0.583. Reflect. It says Roberta decides she will roll 1 number cube at a time before totaling them. If Will rolled a total of 6 and Roberta's first number cube rolls a 2, what is the probability that her second cube will result in a total higher than Will's? So here's what they're saying. If this is Will, he already rolled and he added up his 2 number cubes and got a total of 6. Roberta only rolled 1 of hers and it landed on a 2. And we have to figure out how many ways Roberta can get a number that is bigger than 6. So think about it this way. If Roberta rolled a 2 and a 1, that would only equal 3. A 2 and a 2 would equal 4. A 2 and a 3 would equal 5. A 2 and a 4 would equal 6. So she would need to get a 2 and a 5, which would give her 7, or a 2 and a 6, which would give her 8. So that means she only has 2 chances out of the 6 on the number cube, or a 1 out of 3 chance. Example 2. Javier entered a contest and won a new car. The car's options will be chosen at random. The car could come in yellow, blue, or red. So that is our first thing we're going to highlight. So highlight that, the color, yellow, blue, or red. And could have a 4-cylinder engine or a 6-cylinder engine. So we have 2 choices of engine. The car also could come with or without a sunroof. So that's another option, with or without a sunroof. Javier would prefer a sunroof and would prefer a blue or red car, but doesn't care which engine the car has. What is the probability that Javier receives a car he prefers? So the first thing we have to do is figure out all of the possible outcomes. And to do this, they took the first option and put it right here to list them out. So that was color. And we can see that there were 3 colors. There was yellow, so Y, blue for blue, R for red. Then the second option was an engine. So that came next. And this is called a tree diagram because we can see if the car were yellow, then we would have to branch out because then the car could be yellow with a 4-cylinder engine or yellow with a 6-cylinder engine. And then same thing for blue. It could be blue with 4-cylinder, blue with 6, red with 4, red with 6. There was also a third option for the car, and that was a sunroof. So we're going to have branches coming out to represent the sunroof. So if we look at this yellow option, you could get a yellow 4-cylinder car with a sunroof or a yellow 4-cylinder car without the sunroof. And then we can do the same thing for 6-cylinder. Yellow 6-cylinder with a sunroof, yellow 6-cylinder without. So our first job is to count how many total possibilities there are in this scenario. And if you draw the tree diagram, those will always be listed in your last column right here. So we can just count these. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 possible outcomes. I also want to show you this. If you take your total outcomes from all 3 of these options, so we have the color, which is 3, and we multiply it by the engine, which was 2 options, and then we multiply it with or without the sunroof, which was another 2 options. Notice 3 multiplied by 2 is 6, and 6 multiplied by 2 is 12. So that will also give us the total outcomes. In this scenario though, it was good to list them because now we have to figure out how many of them are blue or red with either engine and have a sunroof. So we can see they circled all of those options, and if we count those up, there's 1, 2, 3, 4. So to find the probability, we would say there are 4 choices that would match Javier's preference out of 12, which can be simplified by dividing the top and bottom by 4 to 1/3. So he has a 1 out of 3 chance of getting the car that he wanted. We are going to do this practice together in class, so you can save it for class.